Welcome to multiple choice question 20 of the 2010 Mathematical Methods Exam 2. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator is not really that appropriate for this question, although you can enter part of it into the calculator to perform a calculation quite efficiently, but there is a large part of the question that needs to be dealt with without using a calculator. For question 20, we have let f be a differentiable function defined for all real values of x, where the function f of x is greater than or equal to 0 for all x is an element of 0 to a. And we're told that if the integral from 0 to a of f of x dx equals a, then we're asked to find what 2 times the integral of 0 to 5a of f of x over 5 plus 3 is equal to. So we're actually going to start by thinking about what a graph of this could look like. What could a graph that has the conditions that it's greater than or equal to 0 for all x is 0 to a look like? So this is just one possible sketch. It's some curved function that's always above the x-axis or equal to it, but between x is 0 and x equals a. And because it's above the x-axis from 0 to a, and the integral value equals a, we can think of this as this having an area equal to a. The next thing we're going to think about is that we have f of x over 5 appearing between 0 and 5a. So f of x over 5 is equivalent to a dilation by a factor of 5 from the y-axis. So a graph of f of x over 5 could look like this. And we now go from x equals 0 here to 5a. And the height of the function remains the same, but it's been stretched or dilated by a factor of 5 from the y-axis. So if we think about areas, if the heights are all the same along this function, but it's been stretched out by a factor of 5, this area must be 5 times the original area in green. So we could write this as being an area of 5a. So now we can get to the problem of actually finding what this integral is equal to. So we're going to write it out slightly differently using properties of integrals that we know. So that 2 can stay out the front, but we can actually separate this integral into two parts. So the first part is just going to be the integral from 0 to 5a of f of x divided by 5 with respect to x. And then we still need to add on to that 2, because this 2 applies to the next integral as well, times the integral of 0 to 5a of the function 3 with respect to x. So this is going to equal 2, and then we're multiplying that by the integral of 0 to 5a of f of x over 5 dx, which is equivalent to the area under the curve over here in purple, which we previously discussed is equal to 5a. And then we still need to add on to that 2 times the integral of 0 to 5a of 3 dx. So to calculate that, we can find the antiderivative. So the antiderivative of 3 is 3x, and we still go between the terminals of 0 and 5a. So this is going to equal 2 times 5a is 10a, and then we add on to that 2 lots of the antiderivative evaluated at the upper terminal of 5a minus the antiderivative evaluated at the lower terminal of 0. So that's how we evaluate this integral. And that's going to equal 10a plus 2. And here we have 3 times 5a gives 15a, and subtracting away 0 doesn't change that. So we have 10a plus 2 times 15a. So that is simply going to equal 40a. So that means that D is the correct answer for this question. So from the examiner's report, we can see that only 25% of students got this question correct. And option B, which was the most common incorrect response, was obtained if the antiderivative of 3 was not found. So if we just had have done 2 times the integral of 0 to 5a of f of x over 5 dx, and then we just add on 2 lots of 3, that would have given you 10a plus 6, which was that distractor which many students fell for.